Hey YouTube, this is Kevin Bolin of Bolin's Small Engine, and today guys I'm just continuing off my prior video in regards to the Troy Bilt pony that had a faulty wire harness, a flooded crankcase, and of course some idler pulleys for the transmission as well as the deck. Now I had mentioned in the previous video that my father-in-law had wanted me to reconstruct a wire harness, okay, that didn't have safeties. And the reason being is because most of the safeties were actually torn off of this mower. So that's actually why that I didn't go through all the added effort of replacing the safeties, okay? In truth, I could never legally sell this mower to someone knowing, okay, that those safeties aren't provided, okay? But with it being my father-in-law, he's the one that's going to be using it. He was completely fine with it. Now with that also being said, as I'd mentioned in the other video, I can't legally place the wire harness myself. I can make it, okay, but I can't legally apply it to this piece of equipment. So what you're seeing before you is not a result of my work, howsoever it is a result of my stepsons, who actually put the wire harness on for me. So bear that in mind, guys. Ergo the the vice grips on the back of the negative terminal. It works, but like I said, it's his twist to getting a proper nut or bolt. Anyway, as I was saying, I'm going to go ahead and show you guys somewhat how I went about wiring this Troy Bilt. Obviously, I can't pull the entire wire harness out wire by wire and show you what I've done, because that video would be hard to follow, and in truth it would probably take about an hour and a half, okay? But I'll do the best that I can to give you a summary of what the back of the switch, okay, the terminals, shall I say, consisted of, okay? I've made a paper to help aid me to show you guys. As you can obviously see, there's a G, an L, a A1, A2. There would have been just a B, a M, and an S. But of course, naturally, I went ahead and wrote down battery, mag, and solenoid. Okay, so you guys will know what those potentially are. Okay? Alright, I'm going to start off by telling you that the ground and the lights, they worked together to provide light, which is pretty obvious, okay? That's typically what most do. Howsoever, the A1, okay, which is like auxiliary 1 and auxiliary 2, if you will, okay? The auxiliary 1 controlled the anti-afterfire celluloid for the carburetor, okay? The A2 controls AC output from the stator, okay? That's your alternating current. And if you guys are curious about alternating current, I will at least show you that on the engine. Basically, you have two wires that come out of a stator that can potentially feed you current to a battery or lights. Typically, your lights are powered off of the AC side or AC lead, okay, of the stator. And that typically is this black wire with no diode. As you can see, there's no diode on this black wire. Howsoever, there is a diode on the red wire that comes off the stator. And the reason being is, this is the DC lead, and it basically, the diode allows the current to be passed out, but not to return, okay? Because if it was able to return, it would basically create like a hot plate, okay? A hot plate effect where it would basically cook the stator, okay? So there's a lot of people out there tempted to pull the diode out of these, okay, and just wire direct. Don't do that, because like I said, the diode does serve a purpose. Anyway, so I don't deviate away from what I initially was wanting to show you guys. The battery position, more or less, on this terminal, or key switch if you will, it basically controls the DC output, which is what I just showed you, okay, with the diode, by connecting the battery supply wire with a fuse holder more or less to the DC wire from the stator. Okay. The mag, which is basically just your kill switch, okay, for your key switch, controls the kill wire for the armature or coil, which is fairly self-explanatory. And of course, then you would have a solenoid wire, which it's pretty much self-explanatory as well. It basically leads back to the master solenoid, if you will, that cranks the engine. And they're typically found on these type of lawnmowers right back here in the back. I may be able to show you the difference between the solenoids if there's any confusion. This, of course, would be a typical cranking settaloid, okay, or settaloid. I like to call it a settaloid, okay. I've been called out by many of my potential viewers, if you will, who are adamant about being assholes, and they want me to say it properly. So here's my attempt, guys, okay. It is a solenoid, okay, technically, okay, but as I said, I call it a settaloid, okay. So, you know, be as it may, that is the cranking solenoid for the engine. This, of course, is the anti-afterfire solenoid, as you can see right here on the bottom of the carburetor. It's the one with the two wires going to it, guys. That's your anti-afterfire solenoid. Just in case there was any confusion in regards to what I was talking about on the paper here. Now note, guys, I would have loved to have taken the wire harness and showed you piece by piece, okay, what I potentially done. But as I said, that video would have been very long, even if it was edited, okay? And in truth, they can be very difficult to follow. Whereas by simply labeling what I've done on the paper, it gives you a better idea to realize where potentially the wires would have went and what potentially they would have controlled on the piece of equipment. So that's the reason that I'm showing you the paper instead of actually showing you the wire harness itself. But for those who wanted to actually see the wire harness to see what kind of job I done, I'll at least humor you. As you can see, there's a big difference here compared to what originally was. You can actually see where I had routed the wire and taped it all up to where it would look proper and applied new wires, okay? Now note that I did try to keep some of the colors of the older wires, okay, so that it wouldn't be so confusing. And of course, you can see here where I basically applied the wires to the back. Now, like I said, guys, the vice scripts are on there just to control the negative cable. I have to laugh about that. Easily, I can put a bolt in that, okay? But by convenience, this is this is just a quick method. So, without further ado, guys, I know that a lot of my viewers, when I finish a project up to this point, they're really eager to hear the engine run. So I'm going to go ahead, without further ado or further I say, and actually fire this engine up to let you see how it runs. So as you guys can hear, not too shabby, runs pretty good. So as I said, not too shabby, runs pretty good. In truth and honesty, I probably should have charged the battery a little more. I've already adjusted the valves. That was something that I mentioned in the other video, and it does great. I do know that the battery was a little low, so it doesn't surprise me that there was a light or minor amount of kickback. Okay, it's not, like I said, it's not because of valves or a compression release. It's simply because the battery isn't really as fully charged as it should be. Okay, but for purposes of the video, I wanted to be able to provide a running engine for you guys, so I kind of rushed the charging, if you will, of the battery. But basically at this point, you know that I have a running engine and that I have a electrical system, wire harness, okay, that actually works. Until the next video, YouTubers.